Have you ever just stopped and really looked around you? I mean, the device you're watching this on, the building you're in, the car you drive. Where does all that stuff actually come from? Well, it's all built from and powered by materials we pull right out of the earth. So let's dig in and see what's really going on.
And this quote just nails it, doesn't it? Minerals are these crucial, often invisible ingredients that make up our daily lives. They're in our food, in our bodies, and yeah, in basically everything we touch. They are, quite literally, everywhere.
So that's the big question, right? How do we get from just a rock in the ground to this incredibly complex world we've all built? Well, that's exactly the journey we're going on in this explainer.
Here's the game plan. We'll start with the basics. What even is a mineral? Then we'll get into classifying them. After that, we'll look at how we power our planet, check out the future of green energy, and finally talk about the huge challenge of conservation.
Okay, let's jump right in. First stop, what exactly counts as a mineral? It's actually a bit more specific than you might think.
So here's the deal. For something to be a true mineral, it has to check a few boxes. It must be naturally occurring, not man-made. It has to be homogeneous, which is just a fancy way of saying it's the same stuff all the way through. And it needs to have a specific, repeating internal structure. Sometimes you find them pure, like limestone, but often they're mixed in with other elements, and that's what we call an ore.
And you find them in all sorts of fascinating ways. They can seep into cracks in rocks, forming these rich veins of copper and zinc. They can be laid down in massive, flat layers, which is how we get coal. Sometimes they're the heavy stuff left behind after weather has washed everything else away. That's where bauxite comes from. Rivers can drop them in valley floors, which is how you get placer deposits of gold. And of course, the ocean itself is just a giant soup of dissolved minerals, like common salt.
So now we know what minerals are and where they're hiding. The next question is, how do we organize them all? Let's look at how geologists classify these treasures.
The first big split is super simple, metallic and non-metallic. Then, inside the metallic group, there's another key distinction, and it all comes down to one element: iron. If a mineral has iron, we call it ferrous. If it doesn't, it's non-ferrous. And just like that, this simple chart helps us categorize some of our most vital resources.
Let's talk about the ferrous minerals. These are the absolute backbone of modern industry. Iron ore is the star of the show. You got magnetite, which is the really fine, top-quality stuff, and then hematite, the industrial workhorse. Then there's manganese, which is like iron's best friend. You need it to make steel strong, but you'll also find it in things like paint and insecticides.
Now, over to the non-ferrous team. Copper is a superstar because it's easy to shape and it's an incredible conductor of electricity, making it essential for all our wiring. And then you have bauxite. This is where we get aluminum. Now, imagine a metal with the strength of steel that's also incredibly light. That combination was a total game changer. It's what made modern aviation possible.
And we can't forget the non-metallics. These are the specialists. Take mica. It has this amazing ability to handle high voltage, which makes it absolutely vital for electronics. And limestone, well, it's a key ingredient in the cement that builds our cities, and it's also used to help refine iron ore. So we have all these amazing materials that literally build our modern world. But getting them out of the ground, well, it's not a simple or clean process. Mining has a pretty significant dark side that we really have to talk about. And the cost is steep. For the miners, there's the constant risk of lung diseases from dust and the ever-present danger of accidents. For the planet, it means scarred landscapes and polluted water. And for all of us, it's the simple fact that these minerals are finite. Once they're gone, they're gone. It's why mining is sometimes called a killer industry.
Which brings us to the other side of this whole equation. We've talked about the materials that build our world. Now, let's switch gears and talk about the energy that powers it all. For centuries, we've relied on what we call conventional energy sources. These are the old standbys: coal, petroleum, and natural gas. They've done a lot of work for us. The only problem? They're mostly non-renewable, and they come with a pretty heavy environmental price tag.
Take coal, for example. What's so interesting is that not all coal is the same. Its quality all depends on how much it's been squeezed over millions of years. It starts as low-grade peat, gets compressed into industrial-grade bituminous, and eventually becomes high-grade anthracite. And the timescales are just mind-boggling. Some of these deposits are over 200 million years old.
All right, take a look at this number. 1,700 kilometers. What on earth could that possibly represent in the world of energy? That number? That's the length of just one major natural gas pipeline in India. Think of it as a massive artery, pumping a cleaner burning fuel from the coast right into the country's industrial heartland.
It's a perfect illustration of the incredible scale of our energy infrastructure.
But our reliance on that kind of energy infrastructure is starting to change. We are now moving into a new era, one focused on cleaner, more sustainable ways to power our world.
And these are the non-conventional, renewable sources. This gives you a great snapshot of the different options we have. We're talking about everything from splitting the atom with nuclear power to harnessing the energy of the sun, the wind, and even the tides.
And the science behind them is just so cool. Nuclear energy works by altering the very structure of atoms. Solar panels turn sunlight directly into electricity. Huge turbines catch the wind. We can even turn farm waste into fuel with biogas, use the ocean's rhythm for tidal power, or tap directly into the Earth's own heat with geothermal energy.
But as we innovate all these amazing new sources of energy, there is another source, one that might just be the most powerful of all, that we absolutely cannot afford to ignore.
And that is conservation. It's the simplest idea, but it's also the most profound. Simply being more efficient and reducing how much energy we use is just as important as finding new ways to make it. Every single watt we save is a watt we don't have to produce, which reduces the strain on the entire system. So if there's one crucial point to take away from all this, it might just be this powerful idea right here. The cleanest, cheapest, and most abundant source of energy we have is the energy we don't use in the first place. And that's something worth thinking about.